Okay, YouTube, in this last video, we're going to continue our exploration of solving quadratic equations, but really confronting this word zero. When we talk about the zeros of a function, what do we mean? So we say we know that the x-intercepts of a graph of f of x equals a times the quantity x minus p times the quantity x minus q, which we refer to this as our intercept form here. We know that the x-intercepts fall at p and q, and we say that this is because the value of the function is 0 when x equals p and when x equals q. If that's the case, we refer to these numbers p and q as the zeros of the function. So when we use the word zero of a function, we really say that any x value is a zero of a function if and only if it makes this statement true right here. So we're looking for x values that when we plug them in cause our function to be 0, and if it's in intercept form, as the one upstairs here is, we would say that f of p equals 0 and f of q equals 0. Then we say p and q are zeros. So another name for a zero is a solution. Another name for a zero is an x-intercept, because that's going to be where our graph intercepts the x-axis. And we also call them roots from time to time. But I'll tell you, when we were looking for solutions in all these last videos solving these equations, we really were looking for the x-intercepts of the graph. And we really were looking for the zeros of the graph, because these are x values that when we plug them back in cause the whole function to be equal to 0. Remember, we always set these equal to 0 when we solve them. So what I want to do in this last example is find the zeros of this function. So finding the zeros of this function, I suppose the first thing we would do is this. We would set the whole thing equal to 0. In other words, set the y value equal to 0 and say, what are the x values that when we plug them in cause us to be on the x-axis or be at a height of 0? So we'd say x squared plus 12x plus 35. So in terms of a solving method, let's choose one here. So we have graphing, square roots, or factoring. And what I can tell you is this. If we're going to use the graphing method here, in this case, I'm actually just going to grab a graphing utility and see, hey, can we tell what the x-intercepts are? So we'd say that x to the power of 2 plus 12 x key plus 35. And I'm just going to hit graph here. And what we're really looking for are the x-intercepts. So what I see here is if I count left, I got 1, 2, 3, 4, negative 5, negative 6, negative 7. So I think that the zeros of this function are negative 5 and negative 7. These would be our solutions, but they're also called the zeros. And so the question becomes this. When I plug these into the function, like negative 5 and f of negative 7, do we actually get 0? So we're going to write this little question mark right here, and let's say we find f of negative 5 here. So if I were to say negative 5 squared plus 12 times negative 5 plus 35, if we simplify this out, we get negative 5 squared actually comes out to be a 25. 12 times a negative 5 is a negative 60, and then we have plus 35. So simplifying this, here I get a negative 35 plus a 35. And so we do indeed get 0. So we would say that negative 5 is a 0 of this function, or it's a solution. And we say negative 7, the same thing. Let's check this out. We say negative 7 squared plus 12 times negative 7 plus 35. Now I get that everybody's probably going to use calculators for this stuff, but I'm going to do some mental math here. We say 12 times negative 7 is actually negative. We get 70 plus 14 is 84 plus 35. And when I subtract this minus this mentally here, we get negative 35. So we say plus 35. We actually do get 0 also. So we would say that negative 7 is also a 0. So these zeros, I also want to find this possibly by factoring. So let's do this. We'll factor this expression here. I notice that this is a trinomial with an a value of 1. So can we think of two values that when we multiply them out, we get a positive 35, and they add up to a positive 12. And I can think of, well, this must be a positive 7 and a positive 5. It'd be easy to check here, our outer and our inner, that we get a 12x in the middle. But because this is a factored expression now, and because we have it multiplying out to be 0, then what we could do is we could set these individually equal to 0. So x plus 7 is equal to 0, or x plus 5 is equal to 0. So solving this here, we get x equals negative 7, x equals negative 5. And we get the same results here for our solutions that we did for the zeros. So just know that when we ask to find the zeros of the function, we're really asking to find the solutions, the x-intercepts, the roots of this function, or for x values that cause us to have a y value of 0. Cheers.